Okay, since Abdulkarim is not talking, let me just quickly give us a recap of what happened yesterday. Yesterday, we introduced ourselves to this particular workshop and we discussed what it takes to take part in this workshop and what you need to excel and complete this particular data science workshop. After that, we dive into our classes proper, whereby one of our facilitators will discuss about what's data science, data analytics, how can we dive into data science, what are the tools we use for data science and data analytics. And from there, we have an illustration on how Excel work. I think this is just a brief recap of what we discussed yesterday. Today, the instructor will join us shortly and we'll start. Please, if Precious is here, please signify so that you can take over the class.
Hello everyone. I think there's a little issue with Precious joining the meeting now. So I guess I would have to start with my part of the presentation first, maybe for some 20 minutes, I don't know, until she's ready. Then she'd be, yes, then I'll stop and she would continue. So I think I might probably just talk about maybe the first slide of my presentation.
Okay, you can move on, ma.
Okay, so sorry, let me first open the document and then um, yeah, can everyone see my screen?
Yes.
Okay.
Yes, we can.
Okay, thank you. Thank you for responding. Yes, so I will be talking about introduction to Python programming for data science. But I think for today I would only be talking on the first slide. Yes, so apologies, I forgot a question mark here. So what is data science? So data science is about data gathering, analysis, and decision making. This is just like to give some more information to what Ms. Precious talked about yesterday. So data science is also about finding patterns in data through analysis and making future predictions. It is a process. It is not an event. Like it has a life cycle, like we can see here. And it is the process of using data to understand different things. Okay, we say data science is the process of using data to understand different things. That's because we are kind of like surrounded by data, like in these times. Almost everything you do is data. Like, is it how many times you log onto your Facebook account every day? Or is it how many times you visit a particular restaurant in the vicinity you live in a month? Like basically almost everything you do is data. So trying to use that information to understand like situations is what is data science. And it is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. In simpler terms, it's about obtaining, processing, and analyzing data to gain insights for many purposes. So almost all of this thing is talking about the same thing. Data science is you gather data, you do some analysis, and you make some predictions out of the analysis you make. So I would like to explain in detail what this data science life cycle means. And I think that's probably maybe all that I will talk about today. So I want you to understand that first thing, if you are going to work as a data science, okay, you're going to be working on problems. And if you have a problem, what you have to understand first is you have to understand what the problem is. You have to have a kind of understanding of the business problem. So I want to give sort of a case example. And because I wasn't prepared to present today, I hadn't put it all together, but maybe I'll just talk about the case example. And if you understand what I mean, I hope so, then it's fine. So assume wait, can everyone hear me?
Yes, please.
Yes, we can hear
Yes,
you.
we can hear you.
Okay. So the first thing, okay, let's use this case example. Let's assume that I established a hospital that started operations 10 years ago, let's say in 2013. And assuming, okay, the hospital started operations in January 2013, and assume the hospital is located at Kaduna, for instance. So let us assume that my the main purpose of establishing, okay, maybe I shouldn't call it a hospital, just like a kind of a health center. So let's assume that the main purpose of establishing the health center is to ensure that every resident of Kaduna that is 20 years and above goes for a checkup, like a complete health checkup, once a year. So assume that I kind of have an arrangement with the state government of Kaduna that, okay, you're going to take care of the expenses and all that the residents have to do is just to come to the hospital, and then we do a total health checkup for them. So let's assume that I now kind of divide the local governments in Kaduna State into 12 groups, and I'm like, okay, each group would come for their checkup in 1 month out of the 12 months we have in a year. So that means everyone will go for a checkup once a year. So assuming, let me see, do I know some places in Kaduna? So let's say, assuming I say, okay, those who live in, let me say maybe Kinkinau or maybe Haimbanki. Yes, let me assume that I say, okay, you come for checkup in January. And those in maybe Zaria, you come in February, and I do the same thing for each of the 12 groups. Every group has its month. And let's assume also that checkups hold on Saturdays. So if it's your month, you could choose any of the Saturdays and you come for a checkup. So assuming we started operations everything was going well, and along the line we started having problems. On some Saturdays we are fully prepared, our staff are ready, and then no one comes for a checkup. And then on some Saturdays we are not really prepared because we do not expect that so many people are going to come on that day. And then we have so many people come for checkup on that day, and then we are not able to work on everyone. So you see, this is a problem. We are prepared on some days and no one comes, and on days we're not really prepared, there are too many people. So it means that we would have to start thinking of how we can predict the amount of people we should expect to come every Saturdays, in order to have everything go quite smoothly. We have to be able to predict that, oh, next Saturday, about how many people should we expect to come for checkup. So to do that, what do we have to do? We can't just, I think, without looking at the information from the past 10 years, for instance, if we were to predict what will happen in the next year, maybe 2024, if we were to predict how many people we were to expect every Saturdays for the whole year, without looking at what happened in the past, we can't predict what would happen next year. So that is the job of a data scientist. So assume I invite a data scientist to do this job for me. The first thing he has to do is he has to understand what my problem is. So that's about like understanding the business, understanding. So all I explained now, he has to understand everything, what's going on, what's the problem we're trying to solve. Like you have to ask questions that would help in finding relevant solutions to the problem. Does everyone understand what I explained by this first? Please, some.
Yes. Yes. Yes.
Yes, because if you don't,
Partially.
okay, partially, okay. The problem is if you don't understand the problem we're trying to solve, then you might end up doing a wrong analysis. You have to understand the problem really. So like the problem now in this scenario is, the problem is we want to be able to predict how many people we should expect on every, let me say, how many people on average do you expect maybe for each of the months, no, not each of the months, on every Saturdays for 2024. So yes, I think I've done my best in explaining the business problem. So the next is data mining.
Sorry, Dama. Sorry to cut you short. Can you just explain where you mentioned that you expect so many people to come and all of you have arrived and unfortunately few people have already have come, and then in a scenario whereby you expect few people to come and then so many people have come. So can you just throw more light on this? That's just my question.
Yes, like things happen. For instance, maybe on some Saturday when we expect so many people to come, maybe for instance, maybe on this Saturday we expect people from Kinkinau to come, and then unfortunately, maybe on that same date, maybe there's a traditional ceremony they hold on that day. I do not know about that, and because of that, maybe everyone goes for the ceremony and no one comes for like the checkup. So like there could be so many factors that could affect people coming on some particular dates. So, but me, like without knowing like what the factors are, I'm like I would keep encountering problems. Like I want to know when to expect so many people to come, or when to expect not so many people to come. So that's why like in the process of data mining, we have to like in this second step of data mining, the data scientist has to like ask questions, and if possible, send questionnaires to the residents in Kaduna and ask them, for instance, he could ask them questions about on which Saturdays do they prefer to go for the checkup, and then ask them maybe reason why they prefer one Saturday to another. So with those questions, we can be able to make predictions that, we expect that by next year, January, for those living in this, for those in the first group that are to come in January, we expect that most of them will come for checkup on the third Saturday of January, something like that. Do you understand?
Yeah, I do understand. Thank you.
Okay, so the second step is data mining. So there's so many different ways that like data scientists do data mining. But I'll talk about it's about like gathering the data you need. But I think maybe in this scenario, I'll talk about just maybe asking people questions about like asking for their names, their ages, which of the Saturdays do they prefer to go for a checkup, and for what reason, or if possible, ask them to like give like a kind of rank that, okay, if all maybe I expect to go on the first Saturday, but if an unexpected problem comes, maybe I would go on the third Saturday, and then maybe I would ask you could ask them to give the best two options, should I say, among the 4 Saturdays in a month. So like I could send a questionnaire to gather my data, but it's not the only way to mine data. You could also get data from open sources, for instance, online. It just depends on the business problem. And the third step is data cleaning. So data cleaning is about looking for inconsistencies and problems in your raw data and taking care of the problems. So assuming I send questionnaires to everyone, ask to everyone in okay, for now I would say everyone, although it doesn't really make sense to say okay, everyone is going to get a questionnaire. So assume I send questionnaires and I ask people for their ages. and then someone puts yes as their age. It doesn't make sense that like yes is an age. And like even if you're not okay giving a machine to do like the whole calculation stuff for us, if like I ask you to give me the average of 5 and yes, you would say it doesn't make sense. Or if I tell you between 5 and yes, which one is bigger, you would tell me it doesn't make sense. So the same thing happens with like the machines or softwares you use to work. So if you do not make sure that like the data you have are like consistent and free of errors and like there are no issues, then you would have problem with making analysis. So you have to clean the data and ensure that everything makes sense. Where you're supposed to have numbers, you have numbers. Where you're supposed to have like strings, let me say you have strings, and like you don't have like empty rows and empty columns. And you also have to make sure you don't have like duplicate rows and columns. They all affect like the analysis and the modeling stage. So you have to clean your data as a third step. And after cleaning your data, the fourth step is data exploration. And in this case, it's about exploring your data, trying to identify trends in the data. It involves like trying to like you plot graphs in this stage to see like the distribution of variables you have in your data. You basically take averages, you find maximums, minimums, just explore and see what you can get from your data. And then the fifth step is feature engineering. And for this step, what you do in this step is sometimes the data you have, even though it makes sense to you, it's something that you can't feed to the software or machine directly. It doesn't like it can't understand what you mean. So you have to be able to convert your data, your clean data, to something that your machine can understand, because it is okay. In particular, we are working in Python, so we are going to be using Python to you're going to be using Python to like make your predictive modeling. It's not something that you do manually. You just get a package and ask it to like make the prediction model for you. So in since you're not doing it yourself, you have to convert your data into like a form that the machine can understand. Let me say it that way. Then the sixth step is predictive modeling, and this is just the stage where you do your employ your machine learning model. You just put thanks to so many packages in Python, where you could just import some package and ask that, okay, you want this you wanted to use this method to do some prediction for you, and then it gives you a result. And the last step is data visualization. After like prediction has been made, so you have to, you know, when you get a problem in the case scenario where I talked about me owning a hospital, you as a data scientist, when you finish all these steps, you have to come back to present what you have to me. But I wouldn't be able to understand all of these steps that you went through. What I care about is just this last step. So you should be able to like visualize the results you have in a way that I, who gave you the problem, would understand the kind of solution you got for me. So this is the life cycle of data science. I don't know if Miss Precious is here, because yeah, I think I used about 30 minutes. Then I will stop here for today and then continue tomorrow.
Okay, thank you.
But Rama, just before you go, I don't know whether if I can ask you again, if you don't mind. Like the fifth step where you mention this future engineering, where you mentioned that you need to convert your data to a language or a format that a machine can be able to understand. Can you just mention one example, like which language do you really mean, and which machine, like computer machine, and which language, like to convert it from what form to what form?
Okay, for instance, if you have like a data that talks about maybe asking people to give some particular rating, and maybe, okay, for instance, every app you use now asks you to rate the app, right? So assuming you are asked to give the rating in assuming you're asked to give the rating in words, for instance, you're asked to say if it's good, bad, or satisfactory, and your data contains good, bad, satisfactory. Usually machine learning, like how should I say, what do I say, doesn't really understand. So if you try to use that, if you try to use like a machine learning model to predict something that has that kind of data, it can work on it directly, because sort of, I don't know, I'm not a computer scientist, so I don't really understand like how systems and algorithm work, but like it doesn't the underlying like program that would help in deploying that machine model cannot read that like those good, bad, and satisfactory that you have in your data. So you have to convert it into maybe a numeric form, so that it can understand what, like, so that it can actually do the predictive modeling for you.
I understand it. Maybe instead of saying maybe yes, maybe you say maybe yes to represent, probably we are mathematicians. So maybe yes to represent maybe one, or maybe not to represent two. I don't
Yeah,
know
something
whether if
like
I
that. Yeah,
maybe
something like that.
all right.
Yeah, something
All
like
right,
that.
thank
Okay.
you.
Not
Don't
necessarily
mind my
exactly
background.
like that, but something like you said.
Uh, so you can hear the shout a lot of. Actually I'm not inside the room, so don't mind my background sound.
Okay, okay, it's fine. Um, I don't know if Miss Precious is here. Otherwise, I could continue.
Hello, you can continue. I think she's still setting up, but I can see some people raising up their hands to ask question. If they can just ask their question
I
and
think
you
they should.
answer them
Please.
before she's just
Okay,
set to finish.
okay.
Yahuza Ridwan, you can ask your question.
Hello.
Yes, we can hear you.
Okay. So, thank you, man. Thank you for the presentation. My question goes thus. Yesterday, while they were presenting, they said there are little difference between the work of a data scientist and a data analyst. So,
Yes.
this cycle that you are showing us, where does the work of an analyst, what is the limitation of an analyst in this cycle? Where does the work of an analyst stops?
Okay. Thank
I
you very much for your question. Do you have another question? Or that's all?
no, that's all. That's all.
Okay. Thank you for your question. The work of a data analyst stops at number 4. After number 4, the next thing a data analyst does is to just visualize what he has from this exploration. A data analyst doesn't do this feature engineering and predictive modeling, but a data analyst, like a data analyst has to also understand the business problem. He also has to do the data mining, data cleaning, data exploration, and then the last stage for a data analyst is to visualize what he has from that step.
Basically, the data analyst doesn't take part in the fifth and the sixth step, but he also visualize data.
Yes.
Thank you very much.
Yes, but like when he wants to make presentation to those who have like the business problem, what he has to visualize is what he has from this step, not like
Oh,
maybe the solution, like predictions he has or
it
anything,
doesn't
because he doesn't
predict.
have any. Yes, although he could make like some, like maybe there's some intuitive predictions you could make from things you see, but not like prediction from a machine learning model. Is there any other question? Or maybe I continue if she's not here.
I see another question. Abdul Wahab, Sajo, you can ask your question.
Yeah, good evening.
Okay, good evening.
Yeah, Ma, I just want to know the difference between inside your slide. I saw the structured and unstructured data. What is the difference between structured and unstructured data? Thank you.
Yes, I was going to talk about that later. Structured data is usually data that comes in like rows and columns. How do I say it? There's a way to like identify all the items you have in the data. While unstructured data usually mostly come in forms of like images. Like there's no particular structure given. There's no particular structure in that data set. I don't really know so much about unstructured data, but structured is just something like what you saw yesterday on the Excel sheets, where you have rows and columns.
Thank you, Ma.
Okay, let me talk about structured and unstructured data. Can you hear me? Okay, so when
Yes,
you're
yes,
talking
we can
about
hear you.
a structured data is the data that they'll give you what you have to do. Like let's say you are making a prediction of a dog and a cat. Like they will give you the actual value. Like probably a dog is represented as 0 and a cat is represented as 1, because when you are doing data engineering is basically converting your data, or feature engineering rather, is when you are converting your data to the way your system will understand and know that you're able to do you want to do prediction about the data. So when you're talking about unstructured data is okay, everybody in this group now, nobody knows each other's name. So let's say the data set we have now contains everybody's name. Like there's nothing like a male, there's nothing like a female. So that's like an unstructured data. So when a data scientist see that kind of a data, it will be so difficult for you to analyze, like, okay, this particular person is a female, this particular person is a male, or this particular person is 20 something years old, this particular person is okay teenager, or this particular person is an adult. So you have issue with those kind of data. That's why we call them unstructured data. And that's when clustering comes in. Then you use some deep learning algorithm to work on that particular data. So basically, structured data is data that you already know what you want to do. You already know the value. But unstructured data is when you don't even understand the data until you do some analysis on it, so you now understand what data is talking about. Do you understand?
Yes, sir. Yes, sir.
All right. Any other question?
I think for now we should stop question and she continue with the class. By the end of the class, they can ask other question.
Okay, so next is why data science. So data science is used in many industries such as banking, consultancy, healthcare, manufacturing, and it has witnessed like remarkable growth due to the abundance of electronic data now, and then there is um, better computing power now, advancements in AI, and there is like demonstrated business value. There's an increased adoption of data science across industries, and this has fueled demand for skilled data scientists. So many businesses now usually have to involve data scientists before probably launching a new product, or to increase maybe the overall revenue in a year or so. So we've been talking about data. So what's data? Data is the foundation of data science, and it's the material on which all the analyses are based. There is the traditional data and there's the big data. So usually traditional data is usually structured and is usually stored in databases, which analysts can manage from one computer. And it's usually in table formats containing numeric or text values. While big data usually not only contain numeric or text values, but could also contain image data, audio data, and it usually has a larger volume, and it's usually distributed across a network of computers. So there are two main data types. There are the numerical and no, are they two? I think yes. I don't know. there is the numerical and categorical data. So numerical is quantitative and can be represented by numbers, and categorical is qualitative and can be represented by labels or names. So examples of a numerical data is like ages, while example of categorical data is, for instance, gender. Gender is categorical. It can be measured. You're either a male or female or whatever. And then we have nominal and ordinal data. So nominal data is a type of data that consists of categories that cannot be ordered. For example, favorite colors. If I ask everyone in this class for his favorite color, and someone one says red and another person says blue, there's no like order between red and blue. I can't say red is greater than blue or blue is greater than red. It doesn't exist. So that's nominal data. While ordinal data can be like ordered from, although it cannot necessarily be measured, but like at least it can be ordered. For instance, when you rate a product between 1 to 5, yes, there was a poll today, I think, about how you liked yesterday's class. So it's like an example of ordinal data, because it's either, okay, it was bad, or it was really bad, not really bad, satisfactory, good, excellent. So like it can be ordered from bad to excellent, but it's not necessarily something that is measurable. And then we have discrete and continuous data. So discrete data takes only discrete values. Like age, for example, is another example of discrete data, because you can either be, okay, you can only be maybe 22 or 23, but it can't be 24.7895, for instance. While continuous data is data that can be calculated, and it has infinite number of possible values and is usually measured over a particular time interval. So an example of continuous data is like how the degree of like the weather over like maybe 1 month. So it's a continuous data that can be measured across time. Then yes, examples of where data science is needed. So data science can be used to foresee delays for flight, ship, or train through predictive analysis, and it can also be used to find the best suited time to deliver goods, and it can also be used to forecast, for instance, the next year's revenue for a company. Maybe let me shed more light. Okay, I already talked about like a case example, and but let me shed more light on this best suited time to deliver goods. So let's assume that you own a delivery company and you have this issue of most times when your dispatch riders go to deliver goods to your clients, maybe they almost always do not meet them at home. Then it means you're probably not delivering everyone's parcel at the right time you should. So you could use data science to like through getting like feedbacks from your clients. You could use data science to predict like the best possible time to send out goods for delivery. Then next is, how does a data scientist work? So to be a data scientist, you're required to have expertise in different backgrounds. I would say, I'm sorry to break this to you, but first you need mathematics. I know if I were to ask everyone in this class if they like mathematics, probably almost half of the class would say no. But you need mathematics for data science. It's an important part of data science. You don't need like something really complicated, but you need to know at least the basics of calculus, algebra, and okay, the more you know, the better. And then secondly, you need to know statistics. Statistics is a really important part of data science. Let me give an example with when I talked about, okay, when in the case of having a health center where people go for checkups. So assume you're trying to get like relevant data for the problem you're trying to solve. It means you would have to ask every resident in Kaduna about maybe their details, their names, ages, when they prefer to go for checkup and all. But like, it's not possible for you to get data from every single individual in Kaduna. So you have to sample. Sample means you get like a smaller part of a larger population, and you use the information you have from that smaller data to smaller sample, sorry, to infer insights onto the larger population. So you see, it means that you have to carefully select your sample. If you select a sample that is too small, it won't represent the whole population. Also, if you select a sample that is biased in what terms? In what terms? Okay, for instance, assume when you are getting your data, you are asking only females in Kaduna. It means the result you're going to get is just peculiar to females and might not represent what is actually the case for like the whole population. That was because you focused on just one part. Just one, how do I say it? Like just one particular set of people. So you have to know how to correctly take samples, and yes, so you need statistics. And yes, statistics allows you to play with data, and it helps in it allows you to extract the insights you need to make reasonable conclusions. And to understand data science, you need to know the basics of hypothesis testing, experiment design. Then next is Python or R programming. So yes, Python is a programming language widely used by data scientists, and it has inbuilt mathematical libraries and functions, making it easier to calculate mathematical problems and perform data analysis. So R is also, let me see if I wrote something on R. No. R is also a really nice programming language, and it was specifically made for like data science. So it's also a really, how do I say it? It's also like one of the most popular languages amongst data scientists. Then databases, you need to understand how databases work. So a database is an organized collection of structured information or data, typically stored electronically in a computer. And a database management system is a software application that interacts with the user, other applications, and the database to capture and analyze data. Then you need to understand machine learning too. So machine learning is used to automate data analysis process and make predictions in real time without any human involvement. Most of the predictions you would be making, you're going to be using machine learning models. So you need to understand how machine learning works too. Yeah, so this was just how do I, is this a vendor? This is just like kind of an image kind of representing things you need to in data science. You need to understand some mathematics, computer science, machine learning, domain expertise, research data processing. And then next is tools used in data science. So yes, assume now that you have all the tools needed for data science. You know maths, you know statistics, you understand how databases work and all. But you still can't like do your job like manually. So you need to understand how to use data science tools. And each tool has their strengths and weaknesses and plays a different role in the data science process. So everyone has its preference, and you just choose whichever works whichever one works for you. As far as it can do, like as far as what you choose can do your job for you, then it's fine. So we are doing Python in this course, but it's not necessary that you use Python programming for your data science career. It's not necessary. There's different tools you could use, and yeah, it's fine. So first, before talking about the tools, we're going to talk about file formats. File formats means the formats in which you could the formats in which your data could be. So data could be stored in different file formats, and some of the most popular are CSV, JSON, XLSX, HTML, and TXT. CSV stands for comma separated values, and yes, I think I made an example of let me see, how do I reduce? I think I made an example of something that looks like a CSV file. Yes, here. Can you see my screen? Where I have Abdul 25M, this.
Yes, we can see your screen.
Yes, so ignore this table part. So a CSV file usually comes like in what we have like written up here. So each line represents a particular information. So for instance, this line gives information about this person, Abdul, and then this second line gives information about the second person. Same thing with the third line. So usually when you import like a CSV file into Excel, you see it as a table like this. Yeah. See. Yeah. Then next is JSON file. JSON file is is okay. JSON. Sorry, there's a typo here. JSON stands for JavaScript Object Notation, and yes, is like a data that is based on a JavaScript object syntax. I've never actually seen a JSON script myself, a JSON file myself, but it's something you could come across like in your career as a data scientist. Next is XLSX file. So this is a Microsoft Excel file. Yes, just Microsoft Excel table, and yeah, format spreadsheet file, and yeah. Next is HTML, and HTML stands for hypertext markup language, and it's used for creating web pages. I don't really know how to explain how HTML file looks like. I've seen some, but I do not. It looks something like web page. Yeah. Then Excel. Okay, yes. So now we're talking about the tools now that you need. Some tools you might need. So first is Excel. So Excel allows you to easily manipulate data with what is essentially what you see is what you get editor. And it allows you to manipulate data without working on code at all. And it's easy to start with, and it's very useful in communicating data to people who may not have programming skills. So like, I think Excel is a really nice way to start your data analyst or data scientist journey, because it's much more easier than all of the other tools you will see here. It doesn't involve any coding, and I think it's quite easy to learn how to manipulate things with Excel. Then next is SQL. Data scientists need SQL, and it's a programming language specifically designed to extract data from databases. And then R is a staple in the data science community, and it's designed explicitly for data science needs. And it's one of the most popular programming environments in data science. And it shines when it comes to building statistical models and displaying the results. Yes, so while like R was specifically built for yes, I'll say it was specifically built for like data science. Python is like more powerful than R, because not only data scientists use Python. Other people in tech, people in software engineering, web design, they also use Python. It's very versatile, and it also has like a really simple syntax that is easy to learn. So compared to many other programming languages, Python is very easy to learn. It doesn't yes, it's easy to learn. So, and then here I have a table with the tools, and yes, what they can do and what they cannot do. So you can use Excel to process data, explore, analyze, and communicate data. You can use SQL to collect data and process data. You can use Python to do all, and you can use R to do all. So depending on what you want to do and which tool you prefer, yes, you could use anyone to do anything you want. Yes, and then yes, this is like talking about how a data scientist goes through the whole data science process. So as a data scientist, you must find patterns within your data and before you must find patterns, you must first be able to organize the data in a standard format. What this means is, assuming you're trying to get a particular information and you have everything like in a very how do I say, unorganized manner. Yeah, it's unorganized, disorganized manner. Sorry. You would need to like organize things to be able to get what you want exactly. I don't know if my explanation is good enough, but yeah. So the first thing is ask the right questions. So you have to ask the right questions to ensure that you understand the business problem, because if you don't understand the problem correctly, you might end up answering, you might end up like with the wrong solution. And then next is explore and collect data. I think I've explained this in the first slide. Next step, you explore and collect data. Third is you process the data. That's when you, like your cleaning stage, where you filter what you need, you remove duplicates, you take care of inconsistent values. And at times you'll need to normalize the data too, because probably the range of values kind of do not align. So you have to normalize them so that they're in a practical range. And then explore the data. That's when you add columns, get averages, do basic statistical and numerical analysis. And next is you find patterns and you make future predictions. And the last is you represent the results. Yeah, I think maybe I'll be stopping here today. Yes, we have 6 minutes left. Probably use the 6 minutes for, we'll probably use it for questions.
Okay, so before any question, I've dropped the attendance on the chat. Please, you can just sign to the attendance. Can everyone hear me?
Yes, we can hear you.
I'm sorry. Do we have any attendance? Do you have any attendance? I don't know.
Yes, I
whether we
just
have it.
dropped it on the chat. I just dropped it on the chat in this Google Meet chat. I just dropped the attendance on the chat. Okay, so please, if you have question, you can just ask your question.
Good evening, everyone. My question goes like this. Rahama, you made mention that for you to be a data scientist, you have to learn some calculation like what is it called? Statistics, hypothesis, and also calculus. So along the way of learning the data science, is there going to be an introduction to all these maths that you mentioned, or you have to go and learn them separately? Like, you know, most of us did mathematics when we were secondary school, and subsequently, eventually, when we join university, like, we are not doing maths anymore. There are a lot of people like this. So most of your prior knowledge in mathematics, you are forgetting them, and now you find it difficult actually to go for it. So along the process of learning it, is there any introduction to the calculus, statistics, and the hypothesis and everything you mentioned? Or you just have to go back and learn mathematics? You have to go and learn it by yourself.
Thank you, Nazifi, for your question. Well, this is a 2 weeks program, and it wouldn't be possible to talk about the basic mathematics and statistics concept in this workshop. But any concrete like data science course you're going to take probably in future, they're usually among the modules you would have to take. They're usually parts where you have to learn like mathematics and statistics that you need for data science.
Okay, thank you.
Yes. And I think in the last part of this workshop, my colleague would be teaching you how to use machine learning models to make analysis. So you would only see how the machine learning model makes the make predictions, sorry, but you do not you would not understand like what the background, like how does this model work. So you would need to go like learn that outside, like after this course. You would need to understand, okay, how does this machine learning model work? How does it come up with its prediction? Although you would not need it when you're, but you need to understand how it works to because it will guide you to know the right machine learning model you should use in any situation you find yourself. So we're not going to talk about the maths and statistics here, but yes, any concrete course you find, you would be taught like what you need for data science.
Okay, thank you. Thank you very much.
What's your question if you have question?
I think there's you shall, right?
Hello. Good evening.
Good evening.
Now, thank you for the presentation. My question is that among the 7 cycles you mentioned, so I think I just want to be sure, like all the first 4 cycles, determine data, particularly data cleaning and exploration, uh, is it only Excel that can be used to do this, or there are other things, there are other softwares that can be used to do those?
Okay, thank you for your
And
question.
are you going to do all this, or are we going to be taught all these processes in this workshop?
Yeah, thank you for your question. It's not only Excel you can use in cleaning data. Python does it too, and I would say probably Python does a better job. You can use R in cleaning data too, and SQL also does some. You could use SQL to do some exploration, although not as much as you would do with Python and Excel. Yeah, but Python does it, and would actually be looking at an exploratory data analysis as part of my practical in this workshop, and we would be cleaning data then with Python. Yeah.
Okay, so your question is, does Excel, it's not only Excel we use,
Yes.
there's Python too, there is R language, you can use Mojo too. I don't even know about this new programming language is used for data science also. Then you can use Tableau. So those are the tools used for visualization. But when it comes to data science, when you're going deep inside data science, you can't use all these Excel, Tableau to do it. Python does it better. That's why you see, majorly if you are considering data science, strictly you have to use Python because it's very easy to use. Though there are other programming languages that you can use, but because of the flexibility and simplicity, they consider Python as one of the best.
Sorry, before I go, this slide, will it be shared on the group?
Yes.
This particular slide. Yes. Okay, thank you.
I think we have Frank Urama next.
Good evening. Thank you for the
Good evening.
presentation. I wanted to make an inquiry, like during the practical section, will there be any, like, let's say sample project or something you guys will do, like that we can see practically how the system works with any of the workspaces or something?
Yeah, thank you for your question. I think because the presenter today couldn't, if the original presenter for today had presented, she would have done like a practical with Excel. And for my own part, I'll be doing a practical with Python too. as I said, I would be doing like an exploratory data analysis. That means I'll take us from, I think, step 2 to 4 in the cycle. And then in the last part of the course, there would also be a practical on like the whole data science process, starting from cleaning and then moving to the prediction analysis stage.
Okay, thanks.
Yeah.
So Rama, who's going to show us a practical class or with exercises you're going to take? Or you are
Yeah,
going to indicate with
with Excel, it's going to be tomorrow. What did you say? Yeah, it's going to be tomorrow, Excel, inshallah. Yeah.
Okay, yes, I'm asking whether okay tomorrow. Right.
Okay, her name, Miss Precious. I don't know if she's here. Probably she could say hi to you. I think she should be here. I can't find her.
Okay. If you have any question, please ask. Okay, we have Muhammad Abbas. Sally, you can ask your question.
Please go ahead. Someone is raising up his hand. Please go ahead.
Okay. Good evening, everyone.
Yeah, good evening.
Yeah. I just wanted to actually commend the organizers of this program, and also can't really wait to see where we will actually be building the project. Then I would also just want to quickly ask, in terms of data capture, when you want to capture or enter data, is it only Excel, or we have other mediums that we can use to actually source for the primary data?
Okay, let me take it over. Let me take it over from there. Okay, so when you are considering on how to get the data, there are different ways to get your data. First and foremost, there is manual collection of data. When you are doing manual collection of data, obviously you have to put it inside Excel. Then we are doing online collection of data. That means you have to collect the data from a particular website. Then there's another one called JSON. JSON is like online version of data. Okay, for example, you're trying to do Twitter based analysis. You want to know the trend about COVID-19 on Twitter. So what you have to do is you have to mine the data. So when you're mining that kind of data, that particular data set is referred to as JSON file. So when you're doing something like that, you have to do with internet, you have to be current. So for you to get the whole analogy of data set from 2019 that COVID-19 has started to present, that means you need a whole lot of time. So something like that is JSON file that will work because it's an online version of collecting data sets. So but most organizations or most people that want you to work on their data, they always have it inside Excel file, or they have it, an Excel file is split into two. So that you have it in CSV file or XLX file. She has already said it. So when you're working with data set majorly, is always in Excel file. So you at least see some company that say, okay, you can get their data online or whatever, because what they do is manual, especially, okay, let's say these network providers now, you don't expect them to get their data from online. Sometimes they get it from individual comments on their social media platform. So by then, when collecting those data, they start putting it inside Excel. Then they will now do some graphical visualization to see what is lacking from their end. Then we also have image data sets, but well, when it comes to image data set, those ones they are stored inside file. Then you have to copy the parts from your system, whereby you have to do some deep learning algorithm also. So we might not talk about all these things, but maybe after the workshop, or probably if there's another avenue for us to have this kind of workshop again, we'll talk about that. But majorly, when you're having a data set, majorly is always in Excel file. Have I answered your question?
Yes, you did. I was actually just worried with one of the things that Ms. Rama talked about, that that's the correctness of the data that you're working with. So I'm just considering the fact that when you have humans entering that data, there might be room for error. But it seems it will still just boil down to the ability of whoever is capturing that data to enter the correct data that is required. That's manually on Excel. So thank you. It's
Yeah.
okay.
So someone is MY Jamad. You can speak up.
Yes, I hear it. So
Gmail,
I
okay.
wanted to be clear. I wanted to find out data
We can't
science.
hear you. Sorry. Please,
Is
can you
data
move closer?
science data science, is it
Okay.
a front end tech or back end?
What did you say? I can't hear you.
A front end tech or back end tech?
I really can't hear you very well. Maybe you should just drop the question on the chat. I can't hear you at all.
Okay. Yusuf, his
Okay,
question is
so
that,
Sorry, can you hear me
hello,
now?
can you hear me?
yes, we can.
Yeah, I said data science, is it a front end tech or back end tech?
Oh. Okay. Data science is a subset of artificial intelligence, not back end, not front end. But a front end developer obviously needs a data scientist. Okay, maybe you are trying to build a breast cancer website. You need some predictive analysis. So basically, you need a data science there whereby they've done the predictive analysis for you and they turn it to API for you to make use in your website. So data science is not a back end or front end. It is a subset of artificial intelligence whereby system reason like human being and give you an accurate value. Do you understand?
Yeah, I understand you now.
Okay, so any other question?
Hello.
Okay.
Thank you very much for this presentation. Actually, I learned it a lot and I enjoy it. So my question here is: before we start the practical session, I had the problem when trying to download Jupyter
Okay.
inside my Python command prompt. So actually, I was guided by Rahama when I was trying to download the Python, and I download Jupyter, and I downloaded it successfully. So issue here is there is one particular notebook that I was asked to go and download inside that particular Jupyter. So that notebook is not even showing at all. Once I click on it, the thing will remain stagnant. It's not even moving at all. I don't actually know the problem. And I was told that if I was able to download the Jupyter, I would be able to navigate Python, even if I'm not using like network, even if I don't have data connection, I'll be able to use it as far as I have the Jupyter. I have
Well,
that
there's a way.
notebook.
I don't know how you call out the Jupyter from your local host on your system. Depending
Okay.
on depending on how you call it out on the local host, determine whether you can access it without internet or not. But
Okay.
there will be guidelines on that, on how to call it before the main practical for data visualization comments. There will be guidelines on
Okay.
how to call it on your Windows
Okay.
system.
Okay. Thank you very much.
You're welcome. So any other question? Okay, so in the absence of no question, I think we've come to the sorry, is there another? Okay, so in the absence of no question, that means we have come to the end of day 2 of 14 days data science workshop. So thank you very much for joining. See you tomorrow 8 p.m. also. Thank you very much.
Thank you very much.
Sorry, are these sections recorded?
Yes, they are, and they will be sent. One was sent to the group yesterday. The other one, today's one will be sent also.
Okay,
Thank
okay.
you.
Yeah.
What if like someone like let's say has the pending task or something and maybe he can't attend the day? What happens about attendance or something?
Well, that's why the attendance is not 100%. It's just 80% of attendance. So if you don't attend one, just try and attend the rest.
Okay.
Yeah. So all right, thank you.
In the case where I have attended yesterday's
What do you
lecture,
say?
and I did know that the attendance. Sorry, sorry to interrupt, but yesterday I was able to attend the full class, but I didn't know that the attendance actually was dropped. I missed yesterday's attendance. So how can I maybe be able to attend for that yesterday? How
Well,
can I be able
that
to
one
amend it?
that one is gone, so you just have to attend the other ones. Don't worry, it's 80% attendance. So and your project also, so don't worry.
All right, all right.
Yeah.